Hi everybody, and welcome to the new HPC Think Tank series. My name is Wolfgang Gensch. I'm a veteran in the HPC community and recently very interested in HPC in the cloud. So this new HPC Think Tank series has been produced by HPC Wire and by the ISC events to come up with the new idea of an event which brings together meetings of the mind, representatives of the HPC community. And today our topic is HPC in the cloud. So having said that, I would like to introduce our celebrities, starting with Kenichi Miura on my side. Ken is Professor Emeritus at the National Institute of Informatics and a fellow at Fujitsu Labs. And he's also involved in Riken's new K-computer, which we all know just made #1 on the top 500 list of the fastest supercomputers in the world. Congratulations, by the way. Next to him is Per Öster. Per is from the CSC Supercomputing Center in Finland, and there he is director of the application services and deeply involved in many of the European grid and cloud projects, clouds recently. And then finally, last but not least, Tom Michael Tam. He is vice president for all products at Mental Images, among others, Mental Ray and the Reality Server. Welcome again. So we now all together want to jump right in the middle. Let me start with one observation which I especially made at this ISC conference, which is focusing certainly on more the top 500 HPC community. But still, while in the general industry, in the enterprises, cloud became a real hot topic, I would say since about last year, real actively. You don't see the same trend or the same fast emerging trend in the HPC community. There might be a couple of very good reasons, and we want to start brainstorming a little bit about that. And later on, we want to think about how to circumvent that. So what are the remedies, what are the actions to be taken to get over that, some of these hurdles. Let's start with Ken. So what do you think? Why do we have this slow adoption of HPC in the cloud?
Okay, I have been involved in the national grid project in the past 5 years or so. It's a high-end, the backbone type grid. And now I'm in charge of the new project which provides the user-friendly laboratory layer grid middleware which connects to the backbone grid. So the grid, the cloud should fit at the user's level or laboratory level as to complement what the grid does. I don't think there's any how do you say, competitive or contradictory situation, but they should be complementary to each other. In the past couple of years, I have been reading some reports on the cloud for the HPC applications, and some reports say that the performance was not as good, and some reports said that it was not as cost effective as it was supposed to be. So they're still, I think, in the scientific world, still sort of a premature stage, and especially the total virtualization of CPU does not really match the parallel processing, because message passing time varies, very much. So there should be more consolidation or unified approach between the grid and the cloud, depending on what the users need. So that's my view.
Mm-hmm. Yeah, thank you. And what about your opinion on that, Per?
Yeah, if I think about, of course we have been looking into this as being a service provider in the HPC space, if we can, can say, instead of being supercomputer center, being a bit more than that. Of course, we look into this and see how we can use the cloud concepts and ideas to improve the services to our users. And there are, of course, specific things there in terms of virtualization, and we have done experiments of extending local cluster resources and like this, and it works pretty nicely. And I see two ways here that we will actually, as computing centers then, the technology behind it, maybe also the business ideas, will enable us to deliver better services actually to new segments of users also. In introducing HPC to research areas that are now emerging and using more and more of computing. If you look, for example, into life sciences and so on. Mm-hmm. And then it's another story if one go into, large size of cluster providers.
Right.
Here we, of course, and that's also where we are moving as a supercomputer centers. The large scale data centers are here to stay. And we will place them where they are hunting for power and cheap power and cool climate. Yeah, and this is there for stay. And the need for computing resources is also here to stay and will grow. And it's just about, as we heard, to make these building blocks and make the fit here really. Right, and we have the knowledge, but it's still work need to be done.
Yeah. So in that last respect, you're of a similar opinion that Ken mentioned, that this is more complementary. So on the top, you have really high-end HPC versus wider use of cloud.
Yes.
Still HPC, but and we want to get back to that.
Yeah.
Different applications, I guess.
But without the base, you never get the peak.
Very good point. Okay. And you think clouds are now here, coming and building a stronger base than ever before?
Yes.
Sounds good. And so, Tom, you recently had made experience in the cloud space yourself in putting some of your codes.
Right. So a year ago, to put it this way, it was really not possible to use the cloud technology for that because we are more focused on the GPU combination. That means a GPU in the cloud was a missing piece there. So it's now there, it's coming as well. And also performance was also a problem, at least on our first measurements we did. We were kind of realizing that the performance in comparison to a real cluster, to a high performance computer was not good enough. But this has changed, so they have made some updates on the hardware side as well as on the system in itself. So when we are now currently porting our technology onto the cloud, and we see, of course, there are some pieces still under discussion, put it this way, areas where we see there is limitation in place, but I'm pretty sure that we can sort that out, and I see that the cloud will definitively give, at least for the rendering aspect, 3D visualization aspect, a lot of benefit, and there will be a throughput to a lot of people using it. So this is definitively what I see.
Yeah, so I started with kind of a slow uptake of cloud computing, especially in our HPC community.
Yeah.
And I think I heard from you that performance at least was an issue. Some still say performance is an issue, perhaps because we are not yet really nicely using the already existing HPC clouds. We have heard the vendor panel before, talking about basically also challenges and realities and benefits in the cloud. And those guys all provide, even now, at least technology, like we have seen Josh with the virtualization for all that, or real HPC clouds from the vendors. So obviously there, the offerings are already there. But they claim performance looks quite good if you use it right.
Right.
But there are other roadblocks still, like so in the enterprise area, especially there is security as a premier issue. What would you think more in the HPC research slash ISVs slash other industries area? Is security, so from your high-end view, for example, Ken?
Oh yeah, well, in the grid environment, we are very keen on computer security and data security, and especially if the industry wants to use the supercomputer at the center, they're very secretive about what kind of data or even what kind of program they are running. You know, that's also confidential information. So we have to be very, very strict on how to partition this system and so forth. But when it comes to the cloud layer, I don't know how that kind of thing can be handled. I still haven't got the good idea. But chain breaks at the weakest link.
Oh,
so
yes.
If you have a
Okay.
combined, hierarchical computing environment, starts small and the program gets bigger and move to the center. So that kind of link between those two is very critical, I think.
Do you see any issue with security in your spaces, like Tom?
Of course. So what you were saying, IP is so 3D data are usually kind of protected by itself because they are new. When an automotive industry is asked to move their content to the cloud, they are always saying no way for us, because the data are so sensible for them that they cannot really move them up. This is one point, and the other point I mentioned this morning as well is the people from outside. It's not only the IP. People from outside can try to get into the cloud and can, for instance, get first images of a car or of a movie which will come out. So these are things which are definitively problematic there. So.
Okay, thank you. And Per?
Well, I
Computer
haven't.
center point of view?
Yeah, and I in that respect, I haven't seen any new problems. I mean, the HPC users are familiar with remote computing, so to say, that they are using a facility remotely.
Okay.
Maybe then, if you go to the corporate case, you have this facility maybe remote, but it's within the corporation, and you have control of networks and everything. So, but here I'm not sure I've seen any real new problems here compared to standard distributed or remote computing.
So that sounds very positive then.
Yeah, in a way, yes. I think it is.
But apart from the data security, there's also the large data you have to send up to the cloud, which the import or the ingestion of 3D data. We are talking about gigabytes, but in the future, I'm sure, and there are already models which are terabytes and maybe petabytes. Yeah. And then you need, of course, the cloud will help you because it has a storage there. This is good, but you have to ingest the data to the cloud, and this is a challenge from my point of view.
Yeah, okay, so to sum up, you still see a few roadblocks which we want to overcome, which has to do with performance, with bandwidth, with some with security. Not so in the end user research side, but definitely in the end user industry side. And I think that is a very good start. It was very encouraging. And for our audience, we might want to point to the analyst panel which follows and to the vendor panel, which we already have seen. With that, I would like to thank you very much. And see you soon again.